Hello everyone, I am Mansi Mahindru from ABES Engineering College, Ghaziabad. So, in this lecture series, we're going to start with Unit 3 of Design and Analysis of Algorithms. And this unit basically focuses on various design strategies to design any algorithm. As we all know, at the starting of this particular subject, it has already been told that this subject mainly consists of three keywords. One is design, analysis, and algorithm. The algorithmic part we have already covered in unit number 1. Analysis part we are covering throughout all the units. And from unit number 3, we'll start focusing on designing part. Like, for example, if any problem statement is given to you, then what can be your approach or what can be your design strategy to solve that particular problem basically will be discussed from this unit. Means there are many design strategies which were covered in this subject, like divide and conquer technique, greedy approach, dynamic programming, branch and bound, backtracking, and string matching. So from this particular unit, we're going to focus on various design strategies of an algorithm. This unit will focus on two of the major design strategies. One is divide and conquer, and another one is greedy approach. So let's start with the session. So this particular video will going to give you a brief summary about what we will going to discuss in upcoming videos related to unit number 3. So firstly, the first design strategy that we're going to discuss in this unit is divide and conquer, and it consists of three subtopics. One is sorting and searching, in which we'll discuss about binary search, and in sorting, we're going to discuss about quick sort and merge sort. And these topics has already been covered in unit number 1 when we used to discuss about sorting. So we'll skip this particular thing in this unit and we'll start with divide and conquer from matrix multiplication, that mainly focuses about Strasson's matrix multiplication and convex hull. These two are very famous example of divide and conquer approach. And after that, we'll start our applications of greedy algorithms, and we'll try to solve each problem in depth so that if you will get any question in your university exam, you can solve it very easily. And after, as per as if you will open any competitive platform, and if you will read any of the problem statement, you will get an idea that this particular approach is running behind that particular problem. So, first of all, we have to understand what is divide and conquer and what is greedy algorithm. So, divide and conquer we have already learned in unit number 1 also. So, divide and conquer is a design strategy in which our main strategy is to divide big problem into number of sub problems, and we used to solve each sub problem independently by recursively calling it again and again till we reach to a solution, or till we reach to a smaller problem which we can solve very easily. That is the major strategy behind divide and conquer approach. And in this particular technique, we'll discuss very famous examples, Strasson's matrix multiplication, from which you will going to get, means there is a possibility of getting 5 or 7 marks question in university exam, and convex hull can be asked for 5 marks as well as for 2 marks in your AKTU exams. And then we come to greedy algorithm. So as we all know, if we move to the English meaning of greedy, or you can say Hindi meaning of greedy is lalchi. So greedy algorithms or greedy approach is used to solve optimization kind of problem. Now, what is this optimization? Optimization means something at the end you want to achieve. Means as a greedy person, if you want something maximum at the end or something minimum at the end, means some sort of benefit you want to attain at the last. So for that you can take help of greedy algorithms. So greedy algorithm will help you to find the local maxima, or you can say a global maximal solution, but it don't guarantee that the solution that you will going to get at the end is a global maximal solution. Means whatever suits you best for that particular time will be the best solution for you, and that one will be the local optimal solution for you. But the solution that you will going to get at the end does not guarantees that this solution is the best optimal solution. So that's the major drawback. And from here, your dynamic programming comes into the picture. But uh, that dynamic programming mainly will be covered in unit number 4. And in this greedy algorithm, we're going to study about 6 applications of greedy approach. One is minimum spanning tree, and inside this minimum spanning tree, we're going to cover 2 approaches. One is Kruskal approach and another one is Prim's approach. After that, we'll move to single source shortest path algorithms. And in this particular approach also, we'll discuss 2 algorithms. One is Dijkstra algorithm and another one is Bellman-Ford algorithm. And after that, we'll move to Huffman coding. Then we'll solve activity selection problem, fractional knapsack, and job sequencing with deadline and penalty. These all applications are very important for placement point of views, for your AKTU point of views, and as well as for any competitive programming question which will be asked in your placements rounds. So if you will going to understand the basic concepts of these problems or the basic computation of all these approaches here in the videos, then it will definitely going to help you to understand the concept behind any problem which you will find on any of the competitive platform like Lead Code, HackerRank, Coding Ninja, or anywhere, right? So this unit is very, very important for placements as well as for your university exams. So stay tuned for all the videos which will help you to solve all the concepts related to greedy algorithms. So these are the references. So thank you so much. Thanks for patient listening, and do subscribe CETL channel of ABS Engineering College Ghaziabad. And from next video onwards, we're going to start with greedy algorithms and all the applications related to that. Thank you.